Welcome to the explainer. You know that classic problem? You kick off a long-running task and it just leaves your users staring at a loading screen? Well, today we're going to tear that apart. We're looking at an awesome proof of concept by Antonio Musara that uses server-sent events and Quarkus to solve this. And it does it beautifully. So, let's paint a picture. I'm sure you've been there. Your user clicks a button, maybe to generate a big report, and what do they get? A spinner. Just a spinning icon. Is it working? Did it crash? Who knows? It's super frustrating, right? Yeah, that's what we call the waiting game. And usually the tech behind it is, well, it's polling, and it's pretty much as clunky as it sounds. The browser is just hammering the server over and over again, asking for updates. It's just a ton of extra work for no good reason. It really is like being on a road trip with a kid in the backseat, just constantly asking, are we there yet? Are we there yet? Are we there now? Your app is doing the exact same thing to your server. It just creates this flood of network traffic and puts a huge load on your backend, all to get the answer, nope, not yet. Okay, but what if we could just stop that? What if we could flip this whole thing on its head? Instead of the client asking, what if the server could just tap the client on the shoulder and say, hey, I've got an update for you? Well, that's exactly what server-sent events, or SSE, lets us do. Think of SSE as a one-way street, The client opens up this connection to the server and then just listens. The server can then push messages down that connection anytime it wants. It's a super simple, standard way for the server to be the one to start the conversation. So look at the difference here. On one side, you've got polling, where the client is just shouting into the void, hoping for an answer. But with SSC, the client is just chilling, waiting, and the server only speaks up when it actually has something important to say. It totally flips the dynamic. And the advantages? They're massive. For starters, it's way simpler than setting up something like WebSockets. It's super efficient because you get rid of all that polling chatter. And the best part? It's just a web standard. It's built right into modern browsers with the Event Source API, and it even automatically handles reconnecting if the connection drops. Pretty cool, huh? Okay, theory is one thing, but how does this actually look in practice? Let's get our hands dirty and dive into this amazing proof of concept from Antonio Musara. You can check it out on GitHub. And this isn't some toy example. It's building real PDFs and saving them to storage. So check out this flow. It's so clean. First, the client says, hey, can you make me a PDF? The server instantly replies, sure, here's your tracking ID, and that's it. The client just starts listening. Meanwhile, in the background, the server is doing all the hard work, using a library called fjdoc to create the PDF and then uploading it to Minio. Once everything is finished, bam, it sends a notification down to the client. No blocking, no waiting, just a simple, elegant process. And the whole thing is built on Quarkus, which is perfect for this kind of stuff. It's using non-blocking REST endpoints so the web layer never gets stuck. It's got an internal event bus to keep the different parts of the app from being too tightly connected. It uses Mutiny for all the reactive, streamy goodness, and of course, a client to talk to Minio. It's just a really slick, modern reactive stack where everything is designed to work asynchronously. All right, let's pop the hood and see how the code actually makes this magic happen. Okay, so everything kicks off right here at this REST endpoint. When that request to generate a PDF comes in, this endpoint does not do the heavy lifting. Nope. All it does is create a unique ID, fires off a message to the internal event bus, and instantly sends that ID back to the client. It's in and out in a flash. So now the client has its ID. What does it do? It turns around and connects to this other endpoint, the SSE endpoint. This is the listening post. And you can see right there in the code, the annotations are telling Quarkus, hey, this endpoint is going to be streaming events. Now, this part is really the core of the whole thing. Look at that return type, multi-outbound SSE event. That multi comes from Mutiny, Quarkus's reactive library. It's basically a reactive stream. You can think of it like a pipe. Anything the server pushes into this pipe on the back end gets sent straight down to the client waiting on the other end. So, if the REST endpoint isn't generating the PDF, who is? Well, that's where this background worker comes in. It's a completely separate component, totally decoupled from the whole website of things. Its entire job is to just sit there and listen for those PDF requests coming off the event bus. And this worker is the real workhorse. It grabs the request, and then it uses a complete future function to do the actual PDF generation and upload. And the key thing is, it does this on a separate thread. This means your main application threads are always free and responsive. Then, when the job is finally done, it just sends the result, success or failure, right back to the event bus. So, this all sounds pretty slick, right? But the best part of this whole POC is that you don't have to take my word for it. You can actually run it and see it all work for yourself. The project even includes a little HTML page to test it out. It's pure, simple JavaScript using the built-in event source object. You literally click a button. The page sends the request, grabs the ID, and immediately opens that SSE connection. Then it just waits. As soon as it hears that PDF_completed event, boom, the download link appears. It's the whole flow, right there in your browser. And hey, if you're more of an API tool person, you're covered too. There's a Postman collection included. You can fire off the first request to start the job, and it'll even automatically grab the process ID for you. Then, the next request in the collection uses that ID to open the SSE connection right there in Postman. You can watch the final event pop up in real time. It's slick. Okay, so we've got this beautiful working system on one machine. But what happens when we go to production? When we have multiple instances running behind a load balancer? Things get a little more complicated. And this is something Antonio, the author, calls out directly. The POC keeps track of all the open client connections right there in the server's memory. And that's totally fine for a single instance. But in a clustered environment, that's a big no-no. And here's why that's a problem. Imagine your user's browser connects to server A, but the load balancer sends the PDF generation job to a worker on server B. When server B finishes, it has no clue that the user is connected to server A. The notification gets lost. The fix? You need an external message broker, something like Redis PubSub or Kafka, to act as a central hub for these notifications. So let's wrap this up. What are the big takeaways here? First, server-sent events are a fantastic, simple tool for these kinds of real-time updates. Second, this architecture, decoupling your web layer from your background workers with an event bus, is a golden pattern for building responsive apps. And finally, while this POC is amazing, remember that for real production scale, you'll want to swap out that in-memory notification system for a proper message broker. Honestly, this project is just a killer blueprint. You can apply this to so many things: report generation, big data exports, video processing, anything that takes time. The full source code from Antonio Musara is up on GitHub, so go grab it, play with it, and think about it. What's the first long-running task you're going to streamline?